Welcome to surveying class. So today we are discussing lecture number 7, unit number 2. So this is the last lecture in unit 2, that is measurements and errors. So and the lecture number 7 will be discussing the reliability and quality of measurement. So let's get started. So in this unit 2, what we are discussing is the measurement and the errors, right? So our main objective here actually to go to field. The objective of this course is basically to go to the field and take the measurements in form of distances or angles, right, or the elevations, anything we have to measure on from the field. And when we take any measurement, there will be error associated with it. So we have seen the different source of errors and different types of error, how to deal with different types of errors. So we have seen the significant number as well, how to round up the numbers, all these things we have seen. So whenever we take the measurements on a large scale we are taking on a field, you have to remember that. So in normally the plot length may be in a kilometer by kilometer, thousands, hundred thousands kilometers. So it is very long distance. Right. So whenever you make the measurement of such a long distance, definitely there will be some error because the land also is not a plain land, right? There will be a, trees on the middle or a drain or valley, hills. So many things will be there. So many obstacles will be there, yeah, on the line. So because of that, it is very difficult to take the measurements on a field if you are considering a large scale any project. So in that case, there will be definitely errors. Error will definitely come on the reading. We can't avoid the error. Okay. So now how much error is acceptable? So now we understand that there will be errors. So we can't deal with without errors. Okay, there will be errors. Now how much we can accept? So what is the acceptable limit? So up to how much, if error is more than certain value, then we can tell, okay, this reading is too much error, we should not take, we should take one more time of reading. So how we can quantify the errors, or maybe how the measurements are reliable, that will be seen in this lecture. So today's lecture has actually two parts. First one is reliability and quality of measurements. So in the reliability, we'll be seeing that, if for example particularly you have taken a measurement, so this measurement will be associated with errors. So we have to compute some parameters and we have to check whether the observed as a measurement we have to consider for our map preparation or the plan preparation or not. So that we call it reliability. And lastly, we have the quality of measurement. So we have some tools basically to find it out how much quality we have in the measurement. So if the quality is acceptable limit, then only we'll consider it for the preparation of maps or plan with these measurements. Otherwise, we have to again repeat the process, repeat the measurements in the field, and we have to do it. So the reliability of a measurement is designated its worth as a measurement value, right? So for example, you go to a site and this is maybe rectangular site, and then you have something, lake type is there at the center. So you have already defined it out for your control points. So these are the control points. So triangulation we have discussed earlier also. These are the control points you made. So now in a plan, basically you have to locate this lake. Okay, so how to locate this lake? So this is the lake. So in a plan view, now we have to locate it. So in that case, what you have to do, you have to take the measurements, right? So from each control point, so for this control point, what is the distance here, and how much it makes angle with the vertical. So this is our north direction, right? This will be our north direction of this plan. So how much it makes the angle, and also what is the distance from this control point. Similarly, from this control point, what is the distance, and what is the angle with the north. Similarly, for this point, what is this distance, right? And how much it makes angle with the north. So all these parameters now we are measuring. Okay, so from different distances we do all these things. So from all control point, basically we measure distances as well as angle. So once we have all the measurements, then we come to our office and then we prepare this plot. We first set the control points on the map, and then we locate this map with these measurements and the angles. So now, so this length is very long, right? It is not in paper, maybe it is 1 centimeter, but in real field it may be 1 kilometer. Okay, because if you consider this, if this is a huge lake, maybe you can consider in Hyderabad we have Osman Sagar or Himayat Sagar. These lakes are huge lakes, right? You can imagine this, each control points are very far to each other, maybe 1 kilometer apart, and this distance is also, in paper it is 1 centimeter, but in reality it may be a 1 kilometer or so. So it's huge. So whenever you take this type of measurement, there will be errors, right? So the reliability of a measurement is designated as its oath as the measurement value. So whatever we have taken the measurement, whether it is really good or not, that we call it reliability. Since the true magnitude of the measurement quality is never determinable, its oath is assent by the making the use of reliability indicators. So originally what is the actual length, true length on a field, that we never know, right? That is our main objective, is to find out what is the distance. So the true value, original value, we never know what is the this length in reality exactly. So what we do, we find it out this reliability indicators. Few indicators will be there which will tell the reliability. So based on this indicator, basically we can tell that how much error is there in the reading and whether it is acceptable or not. So the standard deviation works as an indicator of reliability of a set of observations, and uncertainty associated with it observations in the set provides an indicator of its reliability. So what is it says is that standard deviation is very important. So standard deviation is basically the indicator, reliability indicator. Okay. So what is standard deviation? So in field, basically you understand where we have to take the measurement. Measurement means you have to compute the distances. So these distances you have to compute. So multiple times we will take the distances. So in the first instant, we'll find it out. The value comes for example, 1.05 kilometer. This distance, we measured this distance. This comes up to 1.05 kilometer. Now again, one more time we have taken it. Then we got 1.06 kilometer. Okay, so that we discussed earlier also. This is the uncertain part, and this is the reliable first part. Two part is a significant number, right? Reliable part. Anyway, so second time you got something like that. Now third time again you went for surveying. You got maybe 61 kilometer. Again fourth time, same measurement we are taking fourth time, maybe 0.49, something like that kilometer. So we take multiple measurements for the each distance, or maybe similarly for angle also. It is not like one angle we are measuring. So same angle we are measuring multiple sets. And you see each set will have small variations, because that's what the error introduces, right? And it is a very long distance. So there will be small this type of errors. So now once we get multiple, maybe 10 or 15 measurements for the same distance, then we plot this type of histograms. So histograms are basically drawn, and uh, so the histograms are basically drawn with these measurements, and then ultimately we plot the graph. So for example, we have considered this many plots. Now uh, this type of histogram we have to make it. So histogram will be, number of, so in the first observation we got 1.05, right? So we'll plot, oh, no, 1.05, how much times? So basically histogram, you have to plot it, something like that plot you will get it. So what is this histogram means? Histogram means this is like LS shape, right? This is, we call it Gaussian histogram. So in that, what will happen is the maximum value you will get. So maybe for example 10 times you have done it. So maximum value you will get it near to the mean value. Mean value means 1.05, for example, if I consider. So this will be the mean value. So maximum value will be lying in this range, 1.05, in this range. But some value will be very high, but the quantity also will be less. So for example, let me draw it here. So maybe total, like that, total 100 measurement you have considered. So this length, basically you have measured 100 times, and 100 different values you got it. Okay, so out of 100 value, you will get it almost 60 values. 60 values will be, similar to 1.05. 10 values you will get it 1.0, maybe 1.07. Very high value you will get it. Similarly, 10 value you will get it 1.03. Then maybe 80. Then you have maybe this 5 will consider 5 value you got it, this one 70. Now you have the 15 value you got it 1.0. 1.06, and 15 value you got it 1.04. Okay, so total 100 observation you have taken. So this length you consider total 100 times you have measured the length. So out of 100 times, almost 60 times you got 1.05. 15 times you got 1.06, 15 times you got 1.04, 5 times you got 1.07, and 5 times you got 1.03. Right, so this is the 100 measurement. Approximately I have considered a value. So now you have to plot it, all these things, through this histogram. So how to plot it? Now you draw this axis. So first is 60 times you got 1.05, right? So maybe 1.05 is here at the middle, 1.05. So, and this is the how many times you got it. So this is 60 times, this is 10 times, this is 20 times, right? This is 30 times, something like that. So 60 times means this one. So here you got first value. So first plot we have given. Now next is 15 times we got it 1.06. So 1.06 may be somewhere here. 1.06, 15 times you got it. So 15 times maybe somewhere you were here, you get it. Similarly, next 15 times you got it 1.04. So 1.04 may be here. So 1.04, and then 15 times you got it here. And lastly, you have 5 times you got it 1.707, and 5 times 1.03. So 1.07 will be here. So 5 times means only here, and 1.03 means here. Right, so now you draw a smooth line with all these plots, something like that, this type of shape you will get it. So this shape we call it Gaussian shape. So from there, basically, we can find out what is the standard deviation. So we have to take the average of of the differences, and then we get it what is the standard deviation. So you have studied in the mathematics class also what is standard deviation. So if the error is very high, then what will happen? So in every measurement, in some measurement you will get 1.09 also. So depending on this accuracy, that how much error you get it. So if the standard deviation is very high, that means error also is very high in the measurement. If all the values, if all 100 values are very similar to 1.05, then the values are very accurate, right? So in that case, the standard deviation also will be 0 or very near to 0. So that's why the measurement will be very good. So depending on the standard deviation of a value, we can classify whether the error, whether the measurement is reliable or not. So next, standard deviation, already I have discussed how to plot this type of curve. If a range of variation is narrow to a small value, then the range of error also contracts, right? Rendering the mean value prediction close to the true value. Means, for example, 100 times you have taken any measurement. So 100 times means in almost all 100 times you got same value, almost same value. So in that case, what happens? That means the measurement, whatever you are taking, that is very correct, very accurate. That's why all the 100 times you got very similar value. So that's why this is like for the this is the histogram. If you draw it, in that case, if the measurement is very good, then the histogram will be very narrow histogram. You will get it, something like that histogram you will get it. If it is good, if the measurement is good, then this type of histogram you will get it. And if the measurement has very much errors, in that case you will get something like that histogram. So this range is very high. Okay, so this is the bad measurement, and this type of measurement is good measurement. Okay, so this is the reliability indicator, like with terms of, we call it sigma. Sigma is basically the standard deviation, and mu is the mean value. So you can see here mu is the mean value, and sigma we call it standard deviation. So mu means mean value. If all values are very similar, then the mean value also will be very similar. So in that case, the values in that case, the reading is very good. So the mu plus sigma and mu minus sigma. So basically, if you have all the values, now this is the histogram, so now the new measurement you have taken, and the measurement is, what is the mu value. Mu value means mean value of the measurement. Now the new value you got it, maybe something like that. So in that case, you can understand that although original mean value is mu, but you got mu plus some distance, right? You did not got mu for the new measurement. You got something plus mu. So in that case, the new measurement will have error, and error is how much percentage we denote it. So this, if the error lies in this range, right, means mu plus 0.0647 sigma. So in that range, if the new value lies, then we call it is 99%, 99% accurate value you got it. So if you get the value in this range, then we call it as a 99%. Yeah, sorry, this small range means it is 50%, right? So this small range means the error is actually 50% error, you got it. Now if you get a value here, so in that case this is lying, this 90% value, so the error will be 90%. Similarly, if you get a value here, maybe in that case the error will be 95%. So this is the plot from where we can get whether our value is how much accurate or how much reliable, that we can say, right? So let me again tell you how we have plotted and how we are interpreting this value. So for example, on a field you went and you are finding out the distance. So from here to here you want to find out distance. So this distance may be very long. So you have measured it. So one time you got it, it is 705 meter. First instant. Now same distance again you measured. You got 706 meter. Third time you got 701 meter. Fourth time you got 715 meter. Right. So every time you are getting the different value. Okay. And total maybe 100 times or 200 times the same measurement you have considered, and all the 100 times you got different value. So all the values, if the measurement is very accurate, then all the values will get very near to that. Maybe all 100 readings you will get 705, near to the 705. Okay, but if the reading has an error, then some value will get 705, next value will get 706, 701. So all are very much randomly closed. So in that case, once we have to find the total 100 reading. After you find it your 100 reading, you draw this type of histogram. How we plot it, I have already explained. So for example, here out of 100 reading, almost 50 or 60 reading will be the mean reading, means near to the mean value. Maybe 705 is the mean value. So near to the mean value, you will get almost 50-60%. Some value will get very extreme high, but then that number will be very less. For example, 715. 715 is very high compared to 705, right? The total 10 meter of error. So 10 meter of error, this type of value will get very less. Maybe out of 100, maybe 3-4 times you get this very high number. So that's why this plot here you see number also reduced. So very less times you get very high value. Similarly, very less times you get very low value also. Okay, so this type of plot, once you get this 100 measurements, you got this type of plots. So once you know the plot, now you can tell that if a new measurement again you are taking a new measurement with this line you are taking, in that case the error, if it is if it is 708 or something, if the point is lying in this point, then you can tell that the total more than 90, almost 90%, almost 80% error is there. 90% means here, so it is less than 90, so maybe 80% error is there in this reading. If you get any value maybe very near to the mu, that means you can tell it is very accurate value. So based on this standard deviation and the mean value, we can classify whether the reading is good or bad. So now, as I mentioned in earlier also, the uncertainty is denoted with respect to this type of plots. So basically here the mean value will be there, mu is the mean value and sigma is the standard deviation. So the mu plus minus 0.647 sigma means in this range I am talking, mu plus minus, plus means here, minus means here. So in this range, if any value lies in this range, any value lies, then we can tell the error is 50% error is there in the reading. If any value lies in this range, then we can tell the error may be 50 to 90% error is there in this range. If you get another value in this range, then we can tell the error is more than 90%, almost 90, less than 95% error is there in the value. So like that, with drawing this histogram, we can find it out, we can find out the reliability, like how much, if you measure a distance on a field, we can tell that how much reliable it is, the measurement, how much reliable it is, that we can indicate it. So here a small example I have explained. So a distance, if you consider it is a 10-meter measured, a distance of 10 meter measured having 95% error as 0.98 centimeters. So you have measured total 10-meter distance, and this 10-meter distance has a 95% error, which is 0.98. So if you draw the histogram, so histogram of this measurement, something like that. So last slide already I have explained this. So you have the 95% means this area, right? This entire area is a 95%. Immediately you have the mu, right? So the 95% error is 0.98. So in the last figure, if you send 1.96 sigma, so this distance, so this is 1.96 sigma. So from mu to this 95 percentile area is 1.97 sigma. So how we got 1.96 sigma? That is last slide, you can see from the figure also we got it. So 1.96 sigma is basically sigma equal to, error is how much? 0.9. It is given to us in the question. So from this expression, basically you can find out what is the value of sigma. So sigma will be comes out to be 5 centimeters, something like that. So standard deviation for this measurement now we know. Okay, now what is the question? Determine the uncertainty associated with the observation 10.5 meter for this distance. So the same measurement, now another measurement you have taken, and you observe the distance is 10.05 meter. So how much accurate it is? Now that is we have to find it out. Okay, so the originally how much the length was? Length is 10 meter. 10 meter is, you can consider it as a mu, and in the new measurement you got it 10.05. So how much is the increase? So increase is 5 centimeter, right? 0.05, the difference, right? 10 minus 10.05 means 0.05 meter. If you convert into centimeter, then it will be 5 centimeter. So the 5 centimeter is the more, right? You have mu value 10 meter, and the standard deviation sigma is also already we computed 5 centimeter, and the new observation you got it 10.05. So 10.05 is nothing but mu, which is mu is basically 10 plus standard deviation sigma, plus sigma is how much? 0.05 centimeter. So you get 10.05, right? That means the new observation, whatever we have considered 10.05, this is actually mu plus sigma. So from the last plot, from this histogram, mu plus sigma, how much area is there? That is basically, the reliability percentage. So from there, from the plot, we got 50% actually. So in the last slide, you can check. So for this mu plus sigma value, how much is the total area? It comes out to 50% or whatever it may be. Please check if this value is correct or not. But the main objective is from this plot, basically from this histogram, you have to find out mu plus sigma where it is. So mu plus sigma, if it is there, then whatever is the area inside that will be the percentage. So basically, how we have quantified, how we have said that the measurement is good or not based on the standard deviation. So we take multiple readings for the same length or the same angle, and then ultimately we are plotting these histograms. From the histogram we draw the uh, standard deviation, and from the standard deviation basically we can say that how much reliable the reading is, whether if the reading has more number of errors, more percentage of errors, in that case we have to remove this reading, and again we have to go to field and we have to measure the distances. So now the next topic here is the quality of measurement. So the quality of measurement, having a set of repeated observations, are being tested by using the indicators like so. And as I mentioned earlier also, in the real field we never know the true value, true distance, or the true angle, we never know. So in that case what we have to do is multiple times we do the repeated observation. So same measurement we do multiple times, and we check how much what do we observe in each time. So based on these repeated observations, basically we compute these things: accuracy, precision, and the relative precision. So these are the indicators, or these are the parameters we compute from the reading or from the observations, and from there we can say that how much quality of measurement we have considered. So always our main objective will be to take the high quality measurement. So based on this parameter, basically we can say quality, precision, and relative precision, that whether how much is the quality of our measurement. So always our surveying should maintain the minimum quality. If it is less than that quality, less than that quality of measurement, then we should discard the reading and we have to take the new reading. So now we'll see one by one each parameter here. So accuracy, precision, and relative precision. So now what is accuracy? So the accuracy is a set of repeated observations are being defined as the amount of closeliness of their mean to the population or the distribution of mean. That is closeness of the mean observation to the true value. That means what you have to do multiple times. The procedure is same, like for a distance you have to take multiple time distance, and then we have to plot this type of histogram. So accuracy, if we call this surveying, measurement is very accurate. That means all the values, if 100 times we have taken, all this 100 times value should be very similar, very close, very narrow, right? This will be very narrow in this range. So in that case, that we call it accurate, or accuracy is very high. That is the closeness of the mean observation. So all 100 times, if you take the mean, right, and the mean observation, how much close it is to the true value, that we call it, it is the accuracy. So now you understand accuracy. Now next is degree of accuracy. So degree of accuracy indicates the accuracy attained in the measurement. It is usually expressed as the ratio of error and the associated measured value. For example, the degree of accuracy is 1 in 10,000 indicates that the error 1 unit in the 10,000 unit of measured oblique observed value. So that's how we actually denote, or we quantify the error accuracy, degree of accuracy. So degree of accuracy is denoted in terms of this one, right? So how much error you can make. So it will be a ratio how much error you have made with the total, how much survey or total unit, how much you have done. So that we call it, it is a accuracy, right? So for example, if I tell you a plot, I have drawn it, I have prepared a map, and the accuracy of the map is 1 is to 1 is to 10,000, or 1 is to 1,000, means there is a possibility that every 1,000 unit if I take, then there will be error in the 1 unit. So for example, if this distance, if it is maybe 1 meter in a map, 1 meter means what, 1,000 mm, right? 1,000 mm. So 1,000 mm. So if you take the 1,000 mm or 1 meter distance, there may be a possibility that 1 mm there is a error. So 1 mm there is a error in this reading. That is the meaning. That's how we denote degree of accuracy. Means how much error is there divided by total unit measured or observed. That is, we call it degree of accuracy. So now in the linear measurement means the distance, right? From here to here, we are finding out what is the distance. That we call it linear measurement. So in the linear measurement, degree of accuracy of a linear measurement is usually expressed as the ratio of the probable error. So probable error means what? Probable error means mu plus minus, 50%. It is 50% error, we call it probable error. In the last few slides back, we have seen that histogram with that, how much error is there. So probable error means 50% error plus, and the measured distance. For example, if there is a probable error of plus minus 0.05 meters, so error may be this much, and the distance we have measured this much, and the degree of accuracy will be how much? Probable error is how much? 0.05 divided by the total length measured. How much total length is 5.8464, 584.65. Just do it, then 1 by, you get this value, or if you round it up, then 1 by 11,700. So that is the degree of accuracy. Means 1 unit of length, or 1 meter, if you measure 11,700 meter, then there is a possibility that 1 meter error may have in the measurement. So that is the degree of accuracy, and that's how we compute it. So this ratio is always reduced to a fraction with the numerator as a unit. It's always you have to keep numerator as a unity, and then the denominator part, like that we actually explain. So 1 is to some value, that is the unity, that is the degree of accuracy. So these days the trend to express the degree of accuracy as the ratio of standard error instead of probable error. So nowadays we here we have used probable error by the measured distance, right? But another way, now we are doing degree of accuracy as a standard error. Standard error means the standard deviation. If you see, we have discussed earlier also, the standard error means standard deviation. So from the 100 readings, so we take the 100 measurements. So from the 100 measurement, we find out what is the standard deviation, sigma. So sigma by the measured distance, we call it a degree of accuracy. So this is the degree of accuracy for the linear measurement. Means if you measure as distance, like straight line, or any linear measurement if you do. Now for the traversing, what do you mean by traversing? Traversing means, for example, you started from here, you find it out what is the point here, then again from this point you find out what is this point, like control point you are setting. So this is maybe entire plane area, and from there you started from this point, you know this point is a control point. So from this point you first set this point, number 1, this is number 2, like this is multiple control points you are setting, number 3, then number 4, basically like that. If you go in a circular serial manner, right, number 5. So this type of surveying we call it traversing. Traversing means we'll start from number 0, maybe for the beginning, and from there we find out what is the 1, 2, 3, 4, 5. Again we are going into number 0, and we are from there we are again connecting to number 0. So this type of surveying we call it traversing. We started from point and we traverse from different control points, ultimately come back to the original point, that we call it traversing. So in traversing, basically the degree of accuracy associated with the traverse is usually expressed as the ratio of error of the closeness of the perimeter of the traverse. For example, you are doing the traversing in a circular fashion. So for example, this is the entire area I have considered, right? And you started doing, this is the first point, this is a second point. So basically in a circular point, basically you are finding out this is what is second point, and this is third point, and this is fourth point, and this is fifth point, this is sixth point, and again it meets to 1 point. Okay, so maybe in a circular pattern you are finding out what is this distance. So what is this distance? Like in a circular pattern, each distance you are measuring on a field. So you know total how much you have measured. So maybe 1 to 2, from 1 to 2 you got, that is 10 meter. Then 2 to 3 you got 15 meter. So like that you computed all the distances here. So now if you add all the distances, you get some value. And you know you have done it in a circular manner. That means the radius of circular also, you know, from there you can find out 2 pi r, right? 2 pi r you will get what is the perimeter of the circle and how much you have measured it. So you measured maybe total, if you add all this value, you get 150 mm, 150 meter. Whereas from the 2 pi r formula, you know radius, so from 2 pi r formula you got total perimeter is maybe 155 meter. So in that case there will be error, right? Error of 5 meter. So that is the degree of accuracy is error of closure. So closure means it should be no 155, because you know true value, right? It is a circular pattern you have followed. So error of closure is 5 mm, right? Because as per 2 pi ir you got 155, but in your measurement you got 150. So 5 mm is the error. So 5 mm by total perimeter of the traverse, total perimeter is 155. So that will give you degree of accuracy in the traverse. We are talking about now traversing. If you do this type of traversing, so for example, if there is an error in the closure of 0.1 meters, if the error in the closure means you are closing it, error traversing means you are going starting from one point and you are closing at the same point. So the error in the closing is 0.01 meter in a traverse whose perimeter total length is 200 meters, then the degree of accuracy will be closure error divided by total perimeter, which will be 1 into 2000. So that's what we compute the degree of accuracy in the traverse part. So next we have the angular measurement. So angular measurement means in life, basically in surveying, basically we do so many angular measurements. Angular means angle we are measuring, right? If this is true north and if this is a point, so this point how much it makes from the true north, maybe this is 40-degree angle. So this type of angular measurements also we do so many times. So for the angular measurement, the degree of accuracy is usually expressed as k root n, where n is the number of angle measured. So so what will happen, for example, you are going into in this fish. So these are the multiple closing points, right? This is basically this type of traversing you do, and each angle you have measured using some instrument, each angle you have measured it. So now you know this is maybe hexagon or whatever it may be. So hexagon's formula, you know what is the sum of total internal angles. If it is a hexagon, then you know, right, what is the sum of internal angles middle. But if you are doing a triangle, then sum of all angles will be 180 degree, right? So if you take this measurement, this measurement on a field, and if you add all these three real measurements, it maybe comes out to be 185 degree. So 5 degree more you got it. That is the error. Originally it should be 180 degree, but you got 185 degree, 5 degree error. So the angular error of closure will be in that case 5 degree divided by the number of angle you have measured. So total how many angles you measured? Three angles you have measured. So 5 degree divided root over 3. Whatever value you get it, that is the k value. K is nothing but the accuracy. Accuracy in an angular measurement. So for example, the error of closure you got 142nd in 10 angle. So total 10 times you measured and error you got 140 second. So in that case 140 divided by root over of 10, you get 44 second. So 44 second is the accuracy of the measurement. So now the next we find out accuracy in the leveling. So what do you mean by leveling? So leveling also, for example, this is a cross section of a of a topography, right? So you have a hill, and this is the hill portion, and this is the valley part, right? Some river is passing, maybe for example this is a river. You can understand the cross section of a river I have drawn, right? So now the leveling means basically we are finding out each point what is its elevation. Means you have some standard height from mean sea level, what is the height of this point. So from with respect to this, how much is the below this point, how much down with respect to this line. So each point we are finding out what is the height, what is the elevation basically, means what is the height from the standard line or standard, standard level, that we call it leveling. So now you understand what is leveling. So in the leveling also, what will be the degree of accuracy, usually expressed as k root over of L. So very much important, what is L? L is the horizontal length of the root. So this is the horizontal length of the root, this is a straight line, and k we are finding out, right? So k will be error of closure in elevation. So similarly elevation also, you know, right, what is. So from here you start, so this measurement, this measurement, this measurement. So instrument also if we are changing, so from here we took instrument here, then find out what is the elevation for this point, instrument is now here, like that if you do. So there also we have the closure of elevation. So the error in the closure of elevation divided by the horizontal distance is how much you have covered total, that will give you the accuracy in the leveling. So for example, there is error of closure of 0.2 meter, in the root having a perimeter of 10,000 meter, then the k will be error, how much you got, 0.24 by root over of 10,000. So that is the degree of accuracy in leveling. So like that basically we are finding out the degree of accuracy. Now the next important term is order of accuracy. So the minimum degree of accuracy required for a particular survey and the range, the allowed degree of accuracy is known as order of accuracy. Means how much accuracy is allowed. Okay, for example, you have done a surveying and you computed what is the accuracy for the. In the last few slides we have discussed what is accuracy and how to compute that. So in that computation, so you got some accuracy value. So in different types of surveying, so different accuracy is allowed. For example, if you are doing a, if you are preparing a map for the country level, so in that case accuracy may be 1 is to maybe something like that, 1 is to 100 is allowed. Means every 100 kilometer distance or every 100 meter distance, 1 meter error is fine. If you are doing it for the survey India level, right, very big level, country level, if you are doing the surveying. But whereas if you are doing a very small level surveying, like in a plot for construction, you are doing the surveying, in that case the accuracy, if you get 1 is to 100, means every 100 unit length you have accuracy, I mean error in 1 unit. So this is very high error, because you are doing very small scale, small area you are doing the surveying. So in that case this 1 is to 100 maybe, which is maybe allowed in the country level, whereas in the plan level or the building plot level it is not allowed. 1 is to 100 is very high. So in that case you have to do it 1 is to 10,000. Maybe every 10,000 unit 1 unit is allowed. So that is, we call it order of accuracy, means how much accuracy is acceptable for the particular reading. So in that also we divide the different types of accuracy, like first order accuracy, second order accuracy, third order accuracy. So what is first order accuracy? First order accuracy means very good accurate measurement you have taken. That means one error up to 25,000 units. So 25,000 unit you have surveyed and only one error, 1 unit error you got it. So this is very good first order accuracy. Second order accuracy, for example, is 1 is to 10,000. Means every 10,000 unit you have surveyed and one unit error you got it. Third order accuracy is every 5,000 unit you surveyed and you got one error, 1 unit error. So the error, so like that, so first order accurate order accuracy is very good, second order is comparatively better, and third order accuracy is very bad. So like that, depending on the type of survey, which survey we are doing it in a field level, I mean country level or a plot level. Depending on that, we have to choose the appropriate accuracy level, which is given standard given by the government, and from there we have to make the reading. So if the accuracy is very very low, in that case, for the plot level or the small scale level, we should reject those readings. You have to retake the readings on a field. So now the next important part is precision. As I mentioned, there are three quantities that earlier we have discussed. First one is accuracy, precision, and the relative precision. These three parameters from which we can tell that the quality of measurements, how much quality the measurement measurement has. Based on these three numbers we can classify. So accuracy already we have identified, we understood what is accuracy. Now the precision pretends to the degree of closeness of the observation among the each other. Either each other is actually called, and in a set of repeated observation or the measurement. So precision means, like as I mentioned earlier also, if there is a multiple repetitions, like for this length you are measuring multiple times, 100 times, 200 times the distance you have measured. So in that case, if the all measurements are very close to each other, like all 100 or 200 measurements are very close to each other, then we call it is a very precise value or very precise measurement we have considered. So this is considered, so this precision is considered if the all values are very close to each other. So if there is observed value has very small deviations, the standard deviation is very less, right? That is, we call it, the result is, I mean the measurement is very precision measurement we have considered. Now what is relative precision? Relative precision is defined as the ratio of the precision given measurement and the value of the measurement itself. Thus, if d is a measured distance and sd is the standard deviation, right, then the relative precision will be sd by d, standard deviation by the total measurement we call it, that is expressed as in terms of fraction, right, 1 is to 500 or 5000, whatever it may be, basically by or by parts per million, means ppm. So one part per million, how much it is. So that's what we denote it. So relative precision. So relative precision, we denote it SD by D. SD means standard deviation, means multiple times you have taken the value, the measurement, and from there you computed what is the SD to the mean value. Mean value is D. So from there, this ratio we call it relative precision. Okay. So basically, this is sigma by mu is the relative precision. So now this is the a small example I have explained here. So here, what is the question here? The question is two angles are measured with the instrument having standard deviation. S1 is 20 second and S2 is 30 second. So two angles were measured with the instrument. So two angles, let me draw it here. So you have a plot and you have 3 points, control points maybe. So this angle you have measured. Okay, so this angle you have measured with the instrument having 20 degree, 20 second, basically you have the standard deviation, whereas this angles you have 30 second standard deviation error. So now which instrument is more precise? Okay, no, that is not the thing. Basically, this is a plot and we have this is one point, this is another point, right? This 2 point and this is the north direction. So from the north direction, how much angle it made? So two instrument we have, instrument 1 and instrument 2. Two instrument we have. So first we have used first instrument and we measured what is this angle. So the standard deviation you got it using the first instrument is 20 second, whereas using the second instrument you got standard deviation as the 30 second, right? So now which instrument is more precise? In first instrument you got 20 seconds standard deviation, second instrument we got 30 seconds standard deviation. Which one is more accurate? So you can understand right now from this histogram. So basically, if which instrument will give the very narrow line, so that means that instrument is good, right? Means all values, if it is nearby to each other, in that case that instrument is good, it is very precise also. So if all values are close means what? The standard deviation also will be very small in that case. So wherever you have the small standard deviation, that instrument is good. So S1 will give you less standard deviation. So S1 first instrument is good. So higher the standard deviation, lower the precision. Thus instrument 1 is more precise than the instrument 2. Okay, so S1 is more precise because the standard deviation is less in S1 compared to S2. Now the next question is, find the relative weight of angle measured in the both instruments. So relative weight of angles we are finding out now. So we know the weight of the measurement for the instrument are inversely proportional to the variance. So W1 is the weight we are finding out. W1 equal to K. K is some constant you can consider by sigma 1 square is the variance. Okay, sigma 1 is standard deviation. Right? This is standard deviation. S1 20 is given. So 20 square is 400. So K by 400 is the first weightage. Second weightage is K by sigma square. So second sigma is 300. So 30. So 30 square is 900. So now W1 you have this value and W2 is this one. So now you find that what is W1 by W2 ratio. If you take which is nothing but k by 400 into 900 by k. So if we just do it, ratio we have taken, right? So we'll have the 9 is to 4, right? So w1 by w2 is equal to 9 is to 4. So w1 is 9 and the w2 is 4. So that's how we got a relative weight. Okay, so relative weight we have computed like that. So like that we can solve, and using the standard deviation basically we can compute the reliability. So in this lecture, so this is the last lecture in the unit 2, that is measurement and errors, we have completed. Now we have understand, now we have proper understanding of what is error, how error is introduced, what are the different types of error. Then we have seen in this lecture today, that is how basically the accuracy part, also degree of accuracy, order of accuracy, all these things we have discussed in details. So what we have understood, that there will be errors in the measurements. So we have to, what we have to do is multiple times we have to repeatedly we have to take the observations. So same length you have to be finding out 10 times, 15 times, and from there we plot those type of histograms. From there we do the standard deviation calculation, and all. From there we can find out what is the accuracy of the measurement, because the true value again we don't know, we don't know what is the actual length. So that's why we do multiple times of the measurement, and then from there we find it out those important parameters, and ultimately we conclude that how much reliable our measurement is. So if the accuracy is very less, then we reject those readings. If accuracy is good, then obviously we accept those readings. So that completes our unit 2. So in the next class onwards, we'll be starting our actual horizontal measurement. So as we have discussed in the surveying, our main objective is to measurement, right? Measurement will be horizontal measurement, horizontal distance measurement, or the angular measurement, or the elevation measurement, whatever it may be. So in the next lecture onwards, we'll be starting how we can measure the horizontal distances. Thank you.